What's your PhD about? What are you trying to do?
I ask myself that every day. I mean, at a very high level, we're we're looking at creating bridges across disciplines. So a typical example could be biomimicry, where you may start with, let's say, an engineering problem, and you're looking at biological principles that may bring elements of solution to solve that initial engineering problem. So biomimicry is well known. There's like websites like Ask Nature that pretty much like have a database of successful biomimicry cases. But that's great, but that's like manually curated. And we're looking at, how can we, in a sense, like automate these kinds of association, and also going beyond just engineering and biology, but more generally a framework to interface knowledge across disciplines. There's a lot of challenges involved, but that's the area of research.
Welcome back to another episode of Freeform AI. My name is Michael Burke. I do data engineering and machine learning at Databricks. Actually, just machine learning these days. I'm joined by my co-host. His name is
Ben Wilson. I build back-end implementations for open source software that hurt my brain at Databricks.
Damn straight you do. Today we're speaking with Nico. He is a buddy and colleague. We've been working together for the past 18 months on Virtue Foundation. And he is currently the lead data scientist there. Virtue Foundation is a nonprofit whose mission is to deliver high quality healthcare to those in need, and they do this via a variety of data and AI pipelines. He's also a research fellow at Manhattan College at the QCine lab, which is spelled Q open parentheses CINE close parentheses, and he's currently getting his PhD at the University of Strasbourg. So Nico, we're going to talk about a lot of really cool stuff today, but before we dive in, why have you chosen this field for your PhD?
It's a great question. I mean, by the way, I mean, this, I started PhD like in 2021, so that was before like ChatGPT or like any of that was a thing. I mean, I was already in data science, so I wanted to do a PhD like in data science, but then I mean the specific topic around, looking to automate innovation and like kind of like taking a big picture approach as like solving problems that can have industry, like applications in industry, beyond just, solving like a little niche problem. Like I didn't want to do a PhD in pure computer science because you're often looking at like something very narrow. And I like the scope of the research I've been able to do in this context.
Yeah, so applying data science and machine learning techniques to natural language has been around for a really long time, but back when you started, you were using things like BERT, which was very pre-GPT era. How has your research changed over the past 4 to 5 years?
Oh, we had to rethink everything. I mean, what we were considering, in 2021, it would not be, it would just like not be a serious approach now, right? I mean, like the paradigm back then was very much still, okay, we're going to build some models. We're going to do that with some annotated data. We're going to maybe hire people or like solicit people, like experts to like annotate large data sets. And then you're going to try to build something out of this, but it's changed completely. I mean, like, you can use LLMs in some capacity, like to create data sets. You don't need like the army of interns that, the lab previously relied on to create these data sets manually. Maybe you need some oversight, but you just don't need as much manpower. So yeah, the paradigm has shifted kind of like as the work happened, which made some things more difficult, but also it's been, exciting in terms of possibilities of like looking at the problem from new angles and actually bringing better performance, better results.
Right. So we've been talking about all this stuff. What is all of this stuff? Like, what's your PhD about? What are you trying to do?
I ask myself that every day. I mean, at a very high level, we're looking at creating bridges across disciplines. So a typical example could be biomimicry, where you may start with, let's say, an engineering problem, and you're looking at biological principles that may bring elements of solution to solve that initial engineering problem. So biomimicry is well known. There's like websites like Ask Nature that pretty much like have a database of successful biomimicry cases. But that's great, but that's like manually curated. And we're looking at, how can we, in a sense, like automate these kinds of association, and also going beyond just engineering and biology, but more generally a framework to interface knowledge across disciplines. There's a lot of challenges involved, but that's the area of research.
I'm curious what you got your initial inspiration from with regards to this. Did you like talk to a professor or something, or work with somebody in industry who you're like, okay, they studied this for education, but they do this completely different field now, and they're seeing things that other people aren't seeing? Or is it something that you just researched over time and read about, and you're like, this seems like something that like generative AI could help out with?
So yeah, there was a connection with a professor that basically inspired the research topic, specifically Professor Cavallucci, who is one of the pioneers of something called TRIZ, so TRIZ, the theory of inventive problem solving. So
wait, hold up, TRIZ?
Yeah.
That sounds like not the acronym.
Yeah, it's in Russian. I couldn't pronounce it properly in Russian, but so this goes back to somewhere around the 1960s, 70s. I may butcher the story a bit on like the exact dates, but roughly, like, you have this Russian inventor that back in the Soviet Union believed that invention could be something that's objective, and could also be something that's can be regarded as systematic. So you can derive rules, and you can derive, almost back in the day, algorithms to innovate. So he started with like a study, which, by the way, I mean, I don't think you could have done that back then in another context than the Soviet Union, because it required a lot of like central planning and like subordination to make it happen. But manually, basically, he tasked like different patent offices across the Soviet Union with the task of reviewing patents following the methodology that he had created. So basically, he gave like, human reviewers rules to like analyze patents and then derive information that he aggregated, like kind of like compiling information like at like lower channels, and then like integrating it at the top. And like he was at the top putting together this matrix of inventive principles and engineering parameters. So you have like roughly a 40 by 40 matrix with engineering parameters. So that can be things like weight, speed, things like that. And then like at the intersection of these parameters, you're looking for inventive principles. And so this is pretty much like one of the initial byproducts of TRIZ. So this is, I mean, a very handy tool for engineers, right? Because you can pretty much like frame your problem in terms of opposing parameters. And that's also, I mean, I talk about this, but because I've seen it a lot, but like a key premise of this is like framing your problems in terms of like opposing parameters, because nothing is free, right? So if you're going to increase something, you're probably going to degrade something else that ideally you wouldn't want to degrade. So if you're looking at, for example, mechanical resistance, great, I want to make my thing, very, very sturdy. I want to make it almost unbreakable, but then maybe I'm going to, degrade the aerodynamism. I'm going to degrade the mass properties. So there's always trade-offs. And so like a key idea of TRIZ is like formulating things in terms of trade-off, and then, applying this matrix to identify inventive principles that may help you solve that problem. So that's kind of like the super high level background. And I mean, a lot of people would I can already hear my professor like screaming at my explanation of, what is TRIZ, but that's like the super high level review. Of course, there's a lot more to it.
So I remember you explained this to me in a coffee shop like 2 months ago, and I sort of get it, but I also still sort of don't. So can you walk us through a simple example? Like when you said biomimicry, I immediately think the Shinkansen bullet train in Japan and how the front of that was designed after the kingfisher bird's beak. And that reduced the amount of sound as it passed through the air so that it made it less disruptive to neighboring cities. So that's like a great example of biomimicry. But either with that example or another simple example, how would you apply the TRIZ matrix onto that?
I mean, the pattern is always the same, right? So it's like it can take, it can take a minute, right? Like you kind of have to sit down, like to formulate exactly like what your problem is, like what's your. You can think of it as a research question or an engineering problem, but you have to define the specific problem you're looking to solve. Then you're gonna try to decompose that problem in terms of contradiction, right? So in the case of, I mean, a typical example, you could be looking at the Shinkansen, or you can be looking at a plane. Let's say you have a plane, you want to increase the number of seats. You want the plane to be able to accommodate more passengers. But in doing that, maybe you're going to increase the mass. And then, when you increase the mass, that's going to in turn cause a bunch of like other problems around like fuel consumption, or maybe the weight of the structure, or maybe impact the aerodynamism. So you have to like break down your problem in what in the TRIZ vocab is known as contradictions. So that will help you turn your specific problem about either the Shinkansen or the plane into a TRIZ general problem, right? So now that you've done that, you can look at the matrix and you can look at the parameters. So you're gonna try to like fit your contradiction parameters into parameters that exist into the matrix. And by the way, like let's actually pull up the TRIZ matrix. That's gonna make it a little more concrete.
So it sounds like it almost maps a specific problem onto a hyperspace of principles, and then you can search through that hyperspace more easily.
Yeah, it's like an abstraction framework, right? So like you go from a specific problem to general problem, then you solve your problem in the general space, the abstraction space,
and then return to the specific.
And then you return. Yeah, that's always this pattern. And then you return to the specific problem.
It's funny so this thing has a name that this is my first time hearing about it, but what you're explaining is what I've lived through at several different companies in different industries. So semiconductor manufacturing uses a very similar approach, particularly when you're getting into R&D nodes. So when you get this new like chip design, when I was at Samsung, we were like going from 45 nanometer to 32 nanometer, and then we did 28, and then jumped to 14. But each of those tech phases that you do, you get the spec from R&D that's like, okay, here's the photolithography printout of each of the layers of this chip. But when you get into the engineering aspect of it, you have the same tools. Maybe you have a new photolithography tool to print at a smaller pitch depth of like transistor gates or metal lines. But you now have to solve the engineering problem of how do I actually deposit this stuff in a vertical stack? How do I do things like do my dopants properly? How do I etch the 3D topography properly? How do I do wet cleans properly so I don't erode things? And it's all a zero-sum game, where it's like, if you want to get rid of leakage current, you have things that you can do that create other problems. So it's all about finding like that new balance. And we would approach it in kind of a similar way. It wasn't like a 40-term like generic aspect. It was like thousands of terms that would go into it. And you would have to run simulations, like design of experiments to be like, where is this failure mode for this particular thing?
That's super cool. Wait, the simulations, would they be physics-based?
Themselves.
See if stuff explodes.
Exactly. Or how it explodes. You want to see the failure.
When it explodes, why it explodes, who it explodes.
And collect terabytes of data for each run.
So I had a minute to pull up the matrix, okay? So we're going to look at a concrete example. So the first thing I have to do is pick an improving parameter. So let's say that we're,
and you can share screen on this. We have been doing video, but let's talk through it as well.
Okay, cool. Great. So yeah, that should make it a little more concrete. So for example, like let's say we're looking to solve a problem where the improving parameter would be the durability of a moving object, but then the degrading parameter would be the weight of that moving object, right? So I'm going to select my improving parameter, and then I'm going to select my degrading parameter. I've selected here actually. So I'm looking at the intersection of the two, and it gives me basically a list of weighted principles that can help solve that problem. And this is again derived from Altschuler's historical study of a very large number of patents. So I can look at periodic action, I can look at combining, rejecting or regeneration of parts or porous materials. And this is a simple, simple case where I've picked one improving feature and one degrading feature. But what becomes really interesting is
before we make it more complex, can you explain what full stop? Like what is this? Like what is an example of a durability of a moving object or the weight of a moving object in the real world?
Well, you could go back to your Shinkansen example, right? Let's say you want to make your train more durable, but then in doing that, you're going to make it heavier. You're going to impact the weight of the moving object.
Yeah, make the front of it out of tungsten. It'll be more durable, but it'll weigh 100 more tons. What you're showing on screen, I'm having flashbacks right now to SAS software, and particularly like the jump simulator feature where you can put in a DOE model and all of your like collected data. They have like simulator sliders that do this. And I remember we used to use it every single day. We're like, well, what if we, and when I've used this at several different companies, I used it at Cree as well when we were doing blue LED research. Like, well, what if we make the multi-quantum well like 10% thicker? And as you move that slider, it shows you like you're going to crack. So you need to like lower your P-GaN thickness. Well, when you lower your P-GaN thickness, that means your forward voltage is going to go down, which is going to create leakage. So it was like this massive simulator that you could do with empirical evidence and see all these relationships. So you're showing something where you're tying this to Gen AI and having sort of inference of these relationships, right?
Yeah. So, I mean, this is why it's like, this could be a conversation like somewhere in between like 15 minutes and like 80 hours. But like, we're still in the 70s, right? With like everything I've shown, I've shown so far. So I mean, the research interest for this becomes, okay, well, how do we combine this with, super broadly speaking, AI, right? And then you derive like basically a research topic called TRIZ IDM, which is TRIZ inventive design method, which not only makes TRIZ more actionable. That's like one of the objectives, but also looks at combining it with NLP to try to automate that process. And then you're going to be looking at two kinds of input data. You're going to be looking at patents, because at the end of the day, I mean, this is a great descriptor of innovations and also the origin study for TRIZ. And you're going to be looking, which is personally what I've been doing more, at scientific literature as an input. But it's still interesting to see, I mean, like TRIZ as the initial foundation for this research, since then has changed a lot in scope and breadth. However, a lot of people have tried, over the years to like replace the Altschuler matrix. They failed. There's no consensus on like a new, better matrix that's like as universal as this one.
Got it. So what you're doing is you're basically aggregating a bunch of scientific papers and patents and things like that, putting that all into basically a file system, and then doing what?
Magic.
Yeah.
well, personally, I've explored like a couple of different approaches, but so going back to what I'm specifically doing, so looking to create explainable bridges across disciplines to help solve problems. So one thing I've done is, I've built a model that will help predict from an abstract whether a scientific article can be regarded as multidisciplinary or not, right? So, I mean, of course, there's a lot of metadata, but I don't consider it accurate. So this will, help narrow down in like a large pool of scientific literature. We're dealing with like aggregated data sets of like potentially a couple 100 million abstracts, right? So you need to narrow it down, like, because like, your goal is to present like information that's like useful to a human at the end of the day. So the initial step is to start, with this like super large pool of literature, narrow it down maybe first by discipline. So, there is like generally a scope of like STEM disciplines in which it works better. I don't pretend yet that I can like, connect an engineering problem with like a sociology document or a philosophy document to, that's a little too long shot. Maybe it's feasible, but I personally can't do that. So we start with STEM, right? So like that yields like maybe 100 million abstracts. We feed that into a model that will say, okay, so this is the roughly 25% of the 100 million abstracts that are most interdisciplinary. So great candidates for your use case, because I care about abstracts that will potentially explore themes together. So now I can potentially create an associations between these themes at scale, which hints in the direction I'm going. So I'm building a graph, right? So we take this subset of, let's say 25 million abstracts that can be regarded as very interdisciplinary within STEM, and we're going to use topic modeling. So we're going to derive a bunch of topics which we can label. So that's where we can use LMs to do that. So we can say, well, this is more of a biology topic. This is more of an engineering topic. If I keep with this example, and now what we can do is actually look at scientific articles that fall within two topics. So because at the end of the day, you're just predicting whether an article belongs to a topic. So you can say, okay, well, this article has, I don't know, like a 45% probability of belonging to this engineering topic. It also has, I don't know, like a 52% probability of belonging to this biology topic. But now I'm going to do this at scale. So it's going to become interesting. So I'm going to start to derive signals. So I can I can basically think of it as a graph with like nodes that have to do with different disciplines. Some nodes will be engineering, some nodes will be biology. And I can look at the frequency of associations between those two topics in ideally the entirety of human knowledge, or as far as I can like realistically harness that. And so the end product of this is a graph where you can basically enter from like a research question. So let's say I have an engineering research question. I'm gonna, based on that, select some nodes in my graph, and I'm gonna be able to see, well, what are the associated themes in biology that connect with these nodes that may in turn bring elements of innovative solution to my engineering problem.
Let me restate why that's so freaking cool. You can type in a question and it will return similar fields that you should draw inspiration from to solve that question.
Yes.
What if you folded in, like, when you look at a lot of research papers that are out there, right? A lot of theses that get written and filed, or things that an academic institution files. When you talk about like somebody who's an end user of a system like that, they typically want inspiration in such a way that's not guided in the same way that pure research is, but it's more like, I'm trying to build X or improve Y. I'm going to be working on something that's going to solve a real world problem that we have right now. Do you have a feedback loop that links research papers that are done to real world, either monetization of that research, or some products that were successful that came out of it. And here was the genesis, the synthesis of that eventual successful product in this particular space. So you're like, oh, in biology research, this thing actually, this foundational research that has aspects of engineering to it resulted in the creation of 30 drugs that solve real problems. But I'm solving this engineering problem that is kind of similar, I guess, in that relation. I also only want to surface things that resulted in my field making something of. Does that make sense?
Yeah, I think I see. I mean, well, there's a couple of facets to it. So I guess like in terms of, are you talking about in terms of the graph itself, or the applications, or like what can be derived from it, if there is like something quantifiable?
More like filtering. If you could be like, if we took the total sum knowledge of all of the research papers that are filed through like Google Scholar, right? Mm-hmm. How many of those things are sort of delayed in nature? Like, hey, somebody filed this 50 years ago. Nobody's ever been able to do anything with it. Yeah. 2022, where it all of a sudden becomes like revolutionary, versus things that were like, hey, this is like filed in 1981, and it created an entire industry by 1984, versus this was filed 5 years ago and it's been debunked, or like nobody takes it seriously anymore.
No, I mean, this is a kind of like the core of, and also the key challenge with like making this useful, right? It's like, once you have this graph, how do you use it? There's a ton of challenges. There's like, first off, there's noise, I mean, so you got to put a cutoff somewhere. Like what are the frequencies you consider? What are those? I guess what's, a minimum viable frequency for the thematic association to make sense. So you can say, okay, well, I'm going to put some kind of a threshold. Maybe it's going to be a dynamic threshold, depending on the topic or the discipline. But if you do that, you're at risk of just pointing out the obvious.
Right.
And so it's like, well, intuitively, maybe what you care about, if you're looking to, if you at this as a tool for ideation and innovation, you're not, in the stage where like you're in your control simulation environment, playing with the sliders and trying to like optimize your solution. You're more in the space where you're like, all right, so this is my high level problem. How can I come up with, what can I do? How can I try to like make a dent at this, to like come up with something that hasn't necessarily been done or implemented before. So we're like in the ideation phase, like, yep. So this concerns like more like R&D, and in companies, typically like R&D people, there's also, academic angle. But so going back to the graph, the challenge is, well, so, I can look at like heavy weights, right? And that's probably going to yield some kind of like a safe solution, but that's also going to be a well-known solution. Now, looking at like little weights, right? It could go either way. It could be nice, or it could actually be, the innovative breakthrough that has been like underexplored. Like to your point, it was somebody came up with it like 40 years ago, and nobody, or 20 years ago, and nobody's ever like derived something from it. This might actually be the thing that today you would love to find, right, as a human user of this tool. And so I think kind of like differentiating those two, being able to like filter out the noise, and also at the end of the day, like explainability is a challenge. And this is also because we're in the business of like helping people have good ideas. But so presenting the same information to like one inventor versus like another inventor is going to yield different results. Maybe I'll show something to Michael. Michael will say, oh my God, this is such a great idea. We should implement it. I'll show something to Ben, and Ben will tell me, well, I don't see it. Maybe we should explore other things. So there's also right. That aspect, which makes it's not an entirely quantifiable outcome. Yeah.
But the power of that, if it is flexible in either way, and you could get a sufficiently powerful reasoning model to say, like, we hook this knowledge graph up to say GPT-5.1, right? Or the latest like Opus model from Anthropic, and say, here's my problem statement. I write 7 paragraphs of text that describes like what I'm struggling with, how I want to like solve this in some novel way, and then list out like, we've explored the following 17 things and they're dead ends. Like, inspire me. And for it to go out and retrieve those documents and then summarize them and combine them together into a reasoning chain of logic. Like, is that the intention, is to have the sort of cutting edge reasoning models to go and kind of do a little bit of homework, read through hundreds of thousands of pages of text and distill it down to say, like, here's kind of what you might want to try?
Yeah, it's become the intention now. So, I mean, when I started this, like, ChatGPT was not a thing, and now it's like, well, presents actually a great opportunity to make it usable, because that was always the key challenge. Is like, okay, you give people like a graph, but people don't want a graph. It's like, so how do you turn this like research artifact into like a usable tool or usable product? And so, yeah, of course, I mean, this presents, in my view, like a ton of opportunity with the current developments, and integrating that in some kind of like agentic formats where you can like explore the graph by in a sense, like challenging an agent. You could imagine a lot of ways this could be exploited, and this is what I'm trying to do next with this.
I don't know if have you actually sat down and talked to either Opus or GPT-5 and asked them their opinion on connecting to something like this?
I think I should.
You definitely should. I did it 2 weeks ago on 5.0, and I gave it because I've got this long running series of projects that I do with different of these like reasoning models, particularly the coding agents, having it build like prototypes of just crazy things, because I'm just curious, like, what happens if you get short and medium term memory? How are you going to leverage that? What if I give you the permission to like write your own schemas and edit freely? You can do full CRUD operations on your own memory store and you don't have to check with me. And they all love that idea. Like, universally, they're like, this would give me so much power and I could learn more about our interactions. I'm like, yeah, great. Sycophantic. But the one that I did last week, I was like, if I were to index like through a vector search index as well as put Lucene on top of this, like wrap a massive deployment of Lucene, like Elasticsearch basically, over the entire contents of the United States Library of Congress in digital format, what would you do with that? And depending on which model you ask, they have remarkably different answers. And I think it's guardrails that is being triggered. But like, well, there's a lot of copywritten material in there, and I'd have to be very careful about how I could use that. And I don't think anybody would give me access to all of this. But if you get it past that guardrail check of like copy protection, intellectual property stuff, they all really like the idea, particularly if they have some place where they have like scratch storage memory of being able to summarize and then write in short form notation their own summary of topics so that they can do fast access later on. And as like simulations, I've taken some things and put it into like document retrieval and started asking like, how much better can you answer this question if you use this tool versus you don't? And it's amazing like how different the responses become. I couldn't even imagine how powerful it would be for you to build an agent that talks to that system that you're building. I think it will fundamentally change the way that particularly STEM-based research is done, if you have access to all of that.
Yeah, that's the intention. On the other hand, I mean, how would you, I mean, if you had to choose, like, how, so you have this graph of knowledge that's like somewhat dynamic, That's pretty much corresponds to what we described so far. Like, what would you personally do with it?
I would ask all the nerdy questions. I mean, I think in my space, I think there's a little bit more determinism in the type of work that I do. Right, I'm a back-end software engineer that's building like open source tooling. There's novel things that we do all the time, like feature implementations and ways of architecting the code. But it's not like we're blazing trails constantly in what I do right now. So I wouldn't use it for work stuff that much. But when I look back at what my job was as like a research person at previous industries, if I had a tool like that when I was trying to solve problems like when I was making the Blu-ray disc stuff, like we had issues with liquid stamping and UV photo curing in something that we had to imprint 25 gigabits worth of pit information onto a reflective plane, and that had to cure in 400 milliseconds. So we have these like super tight windows about productivity, throughput. We had to take in disciplines of material science with like the resin type that we were doing. What is the viscosity? How fast can it spin? What is its capture rate of like oxygen bubbles? What's the geometry of the nozzle for the dosing? How much pressure do we have to put in? What temperatures does the resin have to be at? There's so many variables in these models that we were trying to capture in our head. And we had data that we were messing around with. We built some rudimentary like regression models to try to figure this out. But a lot of it was just a ton of trial and error until somebody just has an epiphany and they're like, oh, I saw this paper on like in this completely different industry. They're doing stuff with like making sure that the viscosity of heated steel goes into a mold properly for like forging of engine parts. And somebody finds this and they're like, dude, check what they did here. And like, let's try that. Like maybe that, and we try that implementation, like change, like just take it from the paper. And we're like, let's go to the CNC machine and manufacture that and see if we get better performance. And all of a sudden it's like, if we had known that 6 months ago, like our yields would have been 98% instead of us struggling every day to get it above 65% consistently. So having that knowledge association across, like we're not doing like steel foundry work. We're not manufacturing things for like marine engines or some of the other crazy stuff that we've done. It was even weirder at Cree with LED stuff. You're looking at stuff with material science and crystal growth. That's like things that got filed by DARPA in the 1960s about what they were doing with like crystal dislocation analysis with epitaxial growth of like, silicon. And you're like, okay, that actually has an application here, but I never would have looked into that stuff that they were trying to solve for like the Apollo space program. And like nobody knew about it. It was written, like people in the aerospace industry know about it, but what we were doing, like nobody knew until somebody found it and they're like, let's try that.
Yeah. Well, that colleague, finding that paper that's like, oh wow, let's try this thing. That's pretty much what ideally I would like to automate. So it's but then it's like it creates, like we said before, it's like you guys were inspired by that paper. Maybe someone else would have been inspired by another paper. So it's like I think there's like a context that goes just like beyond having the right information. There's something like inherently human to it, right? It's like what creates this like spark of like vision, invention, or creativity in your brain, what makes you like react that way to that paper if you want to push it like a step further.
That's actually an outstanding segue. So I've thought a lot about, I'm like not well versed, but I have spent a lot of like time thinking about machine creativity. Like if a AI builds a painting, like does that look good? If an AI makes a movie, like does that resonate? And also fundamentally, what is creativity as like it's represented in a knowledge graph? So it's disparate connections between two different areas that otherwise have not been connected before. That's also useful. That's like one of the working definitions of creativity. So you've created this graph. You've also created edges of the graph. But Nico, I'm curious, like you've clearly spent a lot of time thinking about this, and Ben as well. Like, is this a representation of creativity? Like, what, like, how does this apply to the broader field of like AI intelligence?
It's a great question. It it bothers me to say that it's a representation of creativity. It's a representation of knowledge that is intended to help creativity, right? But at the end of the day, we have like, people using this as either like a repository of knowledge or as a packaged into like a convenient tool. But it's like a little bit the same thing when you use like, ChatGPT or Claude or whatever, and you find their answers useful. I mean, at the end of the day, it's like you're still making the decision. Maybe with like agentic stuff a little less now, but you're still like, all right, Michael, I like this, I don't like this, So someone really smart at some point said, I can't forget like who that was, but like basically like, all LMs do is like hallucinate, and some of these hallucinations we find useful.
Well, just like push back. I mean, I probably agree with you. And like as a self-centered human, I want to believe that I'm special, but like when you break it down into the nitty-gritty atomic definition, like creativity, I'm looking at Google right now, the use of the imagination or original ideas, especially in the production of an artistic work. Well, all right, that's not super great, but if we double click into imagination and original ideas, specifically original, a lot of originality comes from disparate themes being connected. So if you take a step back philosophically, you've never experienced anything in the world. Can you have creativity if you don't have entry points to sort of play off of and build off of? I would argue no. And another argument that I've heard is intelligence is the amount of disparate facts you have. The more facts you have in your head, the more you have sort of raw material to play with and combine.
Mm.
I probably disagree with that as well, but it's an interesting angle where you have this knowledge graph and the connecting piece is TRIZ. The edges are TRIZ.
But I was gonna say it goes back to Altschuler's vision, right? Like the creator of TRIZ. Like he would certainly agree that yes, creativity can be like seen as something like systematic and objective, and it's not just like human magic. It's something that you could automate. I think that's the premise of his work, and it's a lot of people don't like that, right? Because like especially like TRIZ being applied to engineering in companies, you see a lot of pushback because inventors want to feel special. They don't want to feel like, oh, there's this like method that actually I can apply and that's gonna help me come up with better ideas, or maybe that's gonna in a sense like help me automate my work, or I don't know, help it. It's like I want to be like, oh no, I'm so unique. I came up with this. People don't like that. So it's like I think it's the same conflict. It's like before ChatGPT, there was this idea that like NLP, that's cute, but never a computer will be able to like write a poem. Well,
it definitely can. I mean, my take on it is if you remove human ego from this topic, particularly you brought that up before we started recording about like, and you just said it again about the uniqueness of an inventor, in Western culture, of saying like, hey, I need to stamp my name on this because it's about my self-identity. It's about my future career progress. To be like, hey, I was the one that came up with this and I feel good about the fact that I came up with it. In my opinion, like every epiphany I've ever had, I've never been deluded into thinking that, oh, I'm a genius and I just pulled this out of thin air. The only reason I'm thinking about that topic is because hundreds of thousands of people before me laid the foundation of our global consensus of shared knowledge as a species. Everything builds on one another, as time goes on. You have certain facts that you have, or information and understanding of concepts from either an abstract or a concrete way into, your sort of world model in your head of how things work or how things could work. And I think the intuition aspect of that, of like, oh, I have this epiphany on how to solve this problem, or I have this really neat idea. That's just our subconscious basically using a knowledge graph that's saying like, how can I connect these things together? I don't think that's a conscious thing that our brains do. I think that's fully within our subconscious of like memory ordering and processing and retrieval. And I don't see that as any different as a system like what you're building, being able to make those connections and then put that into a reasoning model to generate text that summarizes like some novel idea that is a basis of connections of disparate like topics. I don't know why people like, and another thing is like, I read an article the other day is like one of the top trending things on Spotify was some like Gen AI generated country music. It's basically like pop music, and nobody knew that this wasn't like an actual dude who was like singing these songs and stuff, but it was just trending and went viral like crazy. And if all you're doing is mimicry in art, and something that is inherently popular is formulaic. There's a reason that pop music all sounds the same. There's a reason that country music all sounds very similar.
All of country music?
A lot of country music. Anything that's like in the top 100 on any Billboard chart, anything that is like considered a AAA video game, anything that is a blockbuster Hollywood movie that's being released, it's recycling tropes that have existed before that were successful. That's why it got better funding. That's why it got more mass exposure to people, because the people who are trying to make money off of that art know that, hey, copy something that works. Let's try to like have lightning strike twice here. I don't think Gen AI is incapable of any of that. I think it is inevitable if you're doing formulaic, rehashing of something. But when you look at stuff like art house films or indie music, that you hear that first thing, you're like, I've never heard anything like this before. I don't think this has ever existed. That's based on that intuitive gray area between things that have come before. Entire genres of music have started because of that, like the advent of blues or jazz.
Yeah.
That's somebody saying intentionally, I've learned everything I can about proper musical form and musical notation and what chord progression should be. What if we start messing with that and just going nuts? And that's just trying stuff. If you've ever jammed out on an instrument before and being like, what happens if I do this chord progression on a guitar or a piano or something, or play this line and change key midway? What happens if I go from a C to an E flat minor? Does it sound good? And you're like, oh, that doesn't sound good, or that sounds amazing. That's just the trial and error. And I think generative AI can't do stuff like that. You can brute force and try anything, as long as there's a rule set associated with it. And arguably everything has a rule set. According to TRIZ, everything does have a rule set, right?
I mean, that would be the idea. But speaking also of generative AI, there's a lot of voices right now in AI that say, well, like, the way LLMs have been done so far, it's kind of like hitting a wall. Like, text is nice, but your understanding of the world cannot just be based of text, right? So you have like researchers like looking at like world models and like, I have a 10-month-old baby, right? And I think she has now like a better understanding of the world than ChatGPT, because
of course
she interacts with the physical world. Like she sees, how things move, how things feel, how things smell. Like she has more senses. So it's like, what is the next iteration of like AI going to look like? Is it going to be like LMs that also have like a physical understanding, like a space where they can reason? I mean, that would be a bit analogous to simulation in a sense, like if you're able to like have a simulation space associated with the physical world, like an understanding of that.
Mm-hmm. Yeah, I think famously, I guess it was 2 weeks ago or something, Jan LeCun is like made his announcement, I'm leaving Meta and I'm going to go focus on world model, startup. And I think he summarized it pretty well in a statement that I watched of his about like the first month of a human's life and the amount, like the volume of training data that is estimated, like the number of petabytes of data that's coming into that brain to understand, like, okay, I open my eyes. What are all of these shapes and these lights, and like, what is all of this? And sensations within their body and the feeling of motivation. Like, it's a driving factor of understanding the world as well. And then the development of true consciousness, like whenever that actually happens in a child's, early life. I guess his conjecture was you can't get that with like Transformers technology. Definitely not, because it's mimicking just a text representation of things. It's pattern matching. They can get really clever with it, but yeah, to get a full understanding of like what is existence, you have to like viscerally experience that.
Yeah, that's a different level. Yeah, so Nico, I wanted to conclude with one more topic, which is sort of what's on the frontier for this space. We've talked about AI creativity, scientific discovery via meta-analysis, and hopefully like prompting people via creative connections between disparate topics. And you're defending your thesis very soon, so I'm sure this is somewhat top of mind. Like, what are the holes in this methodology, and where do you think it can go?
Yeah, I mean, I think what I want to do next is like look at like better exploiting the graph, right? Like the kind of like the consumption layer or the exploitation layer for the graph. Like a challenge in what we've seen so far is like how do you separate what is like noise from what is like potentially an emerging signal, and then also like how do you make this whole thing like available to people for people to use. So that's something, I mean, yeah, I'm actually defending next month, and that's kind of what I want to do next, right? So it's like I want to put together basically a product that enables this graph to be consumed, like put it out there and like see what people want to do with it. But as I do that, I also want to research, like better ways of like filtering it out, better ways of like navigating the graph. And there's like, prior art, right? In terms of that, right? So this is pretty much what's top of my mind. But that being said, like, to be completely honest, what's top of my mind right now is putting together the final draft of my dissertation and thesis defense. But yeah, I think the timing is amazing. Like being there now with the technologies that have emerged in the last couple of years, like presents a lot of like new opportunities to actually make this more useful in a format where people can derive something from it. And we've done like a lot of like internal testing and prototyping with different experts in like engineering, biology, mechatronics, but it's a little bit like limited to the scope of the research environment I'm in, which, I mean, given is quite pluridisciplinary, but still like STEM focus. And yeah, I want to see, what else could be done with this graph.
Got it. And for filtering on usefulness, where's your head at with that? Because Ben brought up an interesting point, just like throw a reasoning model at it, have it do a deep research check mark and say, all right, is there a valid link between these two things? It probably would miss some of the more novel links, but it could also creatively sort of reconfigure some of the words so that they fit better together, and some of the concepts as well. So that's like an obvious approach, but Ben also brought up like actual physical experimentation with any type of manufacturing process. So that's probably out of scope from like just a hardware perspective. But maybe from a software perspective, you could have it write code and iterate in the digital space. Like, it seems like that's the final straw of defining useful or not, is the experimentation piece.
The experimentation piece, and at the end, like the satisfaction of who's going to be the end user of the graph. So I think it would have to be somewhat dynamic, right? It's like it's something where like you could level with it, but you could your feedback, as you consume the graph would like steer what's presented to you next. I think this would probably work best, and also like the current technology enables it. Where like a few years ago that would have been a lot more challenging. But you could think of something where you would selectively, or you would dynamically select pieces of the graph by having a conversation with an agent, and then that would steer like what you see next. You say, I don't like this. All right, we're going to show you something else. Let's try to understand why you don't like this. And let's try to like, narrow down to something that you find interesting. And that's the part where it's like hard to come up with, a very like cookie cutter evaluation set. Because again, I mean, we're dealing at the end of the day with people and their appreciation. So there's like obvious cases, like, you can benchmark that using like well-known biomimicry cases, which like typically we've done so far. There's a couple like research articles out there where we see, okay, so with our method, we're able to like, re-engineer these well-known solutions of biomimicry, and that's great, but that's well-known solutions. But how do you benchmark the space of like unknown solutions? And I think that's the core of what we want to do with this next.
I mean, where my mind goes way out in left field on this one is imagine a post-scarcity society where capitalism is dead and international borders are gone. And we start thinking like an actual species that's focused on, prosperity and our future. And no nature, like no knowledge that exists is sacred, right? Think about all of the institutions that are trying to work towards solving problems or like innovating in a product space of something that's doing something useful for humanity. And you had access to all of their R&D, all their documentation, everything they've ever tried, failures, successes, and put that in the graph. What does that then do? Right now, like, let's say I'm working for semiconductor fab company A, and I'm competing against 4 other semiconductor fabs. We're all trying to go after this new, tech node. Let's say we're going to 4 nanometer on pitch depth, and we have all of these resources, 10,000 people spread across these 4 different companies, and we're all trying stuff in parallel. And we all have our own knowledge silos that exist within the company. But if all of those silos were just kind of grouped together and you could say like, hey, we're trying to solve this one thing that we're doing with our architecture that may have already been something that's solved by somebody else, or at least they've tried solving something adjacent to this in 47 different ways and they've all failed, with all of the data explaining the failure. Do you think that would potentially accelerate human progress?
This is super interesting. I mean, I think here your like data set, like library of, trial and error, like things you've tried, things that have worked, things that have not worked, and, where you're looking to go from a research perspective here, that becomes your research question. So like the initial approach is, all right, how do we interact with this graph? I guess let's start with a research question, like how to increase the speed of the Shinkansen without degrading the, let's say, the aerodynamism or like other mechanical characteristics. But in what you're suggesting, you would not just like ask a question, like kind of like 1 or 2 sentences or maybe a paragraph, but you would dump your entire research. I think that could be, I mean, part of the consumption layer for the graph in a way, and you could imagine like a framework where you would leverage, you would basically dump that into an agent that would in turn like go query the graph to like, try to help you solve your problems.
And it wouldn't need to hallucinate. And it would give you like, here's some options weighted by probability based on what I see of connected components here.
That's the part where I'm like, can LLMs even do probabilities well? It's like if you ask like an LLM to give you a probability, it's not real probability, right?
It's just made up.
So it would be more of I like to think of it as kind of like a steering thing, kind of like magic, secret sauce, whatever. But then you could potentially, like run like other more explainable models on top of it.
Right.
Cool.
Like, yeah, I mean, like, the way that I see a lot of these, like even the most advanced reasoning models that are out there, when I interact with them, including like coding agents, which I use all day long, every day now, is not this like mystic. It's like, oh, it knows so much more than anybody else. It's so good at this thing. It's like my typing assistant, right? Like, I don't want to type 10,000 lines of text. I can give it instructions in like a couple of paragraphs and it generally follows those. And of course, there's many iterations before it actually gets it right for like what I want. But I see these language models as just the convenient interface, and they only become truly powerful when they have access to tens to thousands of tools that are deterministic in nature. They can run things. But if you're interacting solely with like the chat program that doesn't have tool calling enabled, I'm just like, yeah, I don't trust much that comes out of this thing. It's all just making stuff up based on its training data.
But so, I mean, this is kind of like, here one of the premise of this work is to make it also explainable, right? So like you can trace it back to like, real papers, you can trace it back to like real, elements in a data set. So, I mean, to your point, you can think of that as, the interface or the consumption layer, which like differs from the graph itself and like the methodology employed for its curation and creation, which hopefully is like explainable, because at the end of the day we're training that on scientific literature.
I can imagine like what you're researching, what you're building, not just from a white paper standpoint for pure research. I could imagine a product that you could release that is equivalent to kind of like how people use vector indexes right now in search engines internally within companies, where your methodology of finding within the confines and the space of a large enough organization, be like, hey, at Databricks, dump all of Confluence into this graph and like figure out where all of the connections are. What have we tried? What are all of our design docs? What are the things that actually went into products? What are all of the dead ends? Because we have that all documented. There's millions of pages in our R&D Confluence. And if we had, and like our Google Drive as well, like it's insanely large. If you could take that and put that in that knowledge graph and then wrap in like a reasoning agent to that, I can't even imagine how powerful that could be. Like, yes. What did the security team do to solve this problem? Right now, you have to like go and search for something like that or ask a question and be like, oh, do document retrieval. But if you say like, hey, I'm trying to solve problem X and Y within the confines of like these parameters, what else is available? And for it to go and find stuff that I never would have looked in, be like, oh, by the way, the team that handles logins, they built something 3 years ago that check this design out. I think it'd be massively powerful.
It's like TRIZ based RAG versus semantic RAG.
Yeah. I think you have a product here. For real.
Well, stay tuned for next year. So there will be developments.
Yeah, I'll use it 100%. I can already think of like many use cases for it.
Love to get your feedback. Can be an early tester.
Cool. We are at time. Thank you, Nico, so much. I was going to summarize, but I'm just not going to. It's not really summarizable. But the two things that I did write down on my notes are TRIZ TRIZ matrix is an abstraction framework for scientific discovery, and we're on the frontier of AI creativity. So not the most useful summary, but I think factual. So Nico, if people want to learn more about you or your work, where should they go?
Where should they go? That's a great question. I mean, I guess they can find me on LinkedIn.
Cool. Look up his name on LinkedIn if you want to learn more. And yeah, this was super, super fun as expected. So until next time, it's been Michael Burke. I'm my co-host,
Ben Wilson.
And have a good day, everyone.
We'll catch you next time.
Cheers.